is substitution. Who would like to read? Allison, yeah, go ahead.
The substitution method is used to solve a system of equations by solving the equation for one variable or substituting the result expression into other equations. The steps of the substitution method are shown down here.
Okay, perfect. So this, I don't want you guys to write this down, the whole thing, because it's actually, we'll be like, just look what I have. I'm going to copy it into every single slide. So you don't need to copy it down right now because you will see it the whole time. But just that first sentence, okay, what I highlighted. So the substitution method is one method. We're going to learn a different one tomorrow, but it's one method for solving a system of equations. And for now, just write it down. We'll go through it together, as always. I know definitions never make sense at first, but it'll all come together in just a moment. Does anybody still need a couple more seconds?
Me.
Okay. So as you guys finish writing, I just have a question. What is another way to say substitution? What is a synonym for substitution?
Replacing
Yeah, that's a good one. Replacing,
or replacement?
replacement. Let's do replacement. Technically, that is more grammatically correct. Replacement, so it's like replacing something. And in algebra, what's another way? What's something that I can say that means the same thing as substitution? Alyssa, go ahead and put it on public because you got it. Yeah, plugging in, exactly. Exactly. So today we're going to be doing a lot of plugging things in. So it's going to be very important today especially, but also kind of all this week. We're going to be doing a lot of writing in math, like solving things on paper. It's going to be very important that you guys keep things very neat, okay? So as I write it on my slide, try to keep things just the way that I write it because I'm going to show you a way to organize everything very neatly. Today's problems will be on the longer side. They're not super long, but they require some organization. So just make sure that that's something we do today. So let's just take a look at one example. We're going to be following these 3 steps that are written down below. So here's my system of equations. I have 2 equations. And Can somebody remind me, what does it mean to solve this? If I solve it, what am I trying to find?
X,
The x and
the Y.
the y. Find x and y, because our end goal is to get a coordinate point, x comma y. That's always the goal at the very end. So I start out, I have two equations, but right now I have two equations and two variables, and I don't know how much each of them are. I don't know what x is, I don't know what y is. So step one tells me to solve one of the equations for its variables. What that means is, and this is where you can begin to write these steps down, but like I said, I have them on every single slide from here on out, so if you don't copy it down right away, it'll be on the next slide. So when I say solve one of the equations for one of its variables, what that means is you want to isolate x or y, either one. So the first step is always to isolate the x or isolate the y. But sometimes it's already isolated for you. So take a look at our system. Which equation, number one or number two, already has a variable that's isolated? Remember, isolated means all alone.
Number 1.
Yeah, number one. Number one already has the y, that is, it's just all alone, y equals 4x. So sometimes step one is already done for you. Sometimes you can skip it. So now I'm gonna go ahead and move on to step two. And to answer a question in the chat, yes. So what I would do, let me pause. What I would do is write these 3 steps in the corner, like the top right corner of your notebook, so that you have them there to reference throughout the class. So right now you can go ahead and start writing them, but if you don't finish it right away, remember, I have it on every single slide today. So don't rush through it, just take your time writing it down. So now we're on step 2. Step 2 says, substitute the expression from step 1 into the other equation and solve for the other variable. So what does that mean? Substitute, remember what we said. What does substitute mean in algebra?
Plugging in.
Plug in. Good. So we're going to plug in whichever equation is already isolated. So remember, we already said that equation number 1 is the one that's already isolated. What I'm going to do is I'm going to plug equation 1 into equation 2. So this is what this is going to look like. Ready? So my y is already by itself. So I'm going to take everything else, 4x, and I'm going to plug it in for y. Let me say that one more time. Since I already know that 4x is equal to y, right? 4x is now the same thing as y. If I say y, I can say 4x because I know that they're equal to each other. So what I'm going to do is I can take that 4x and I can plug it in wherever I see a y. So I'm going to give you guys a second to write that all down. And let me know if you have any questions about why I did that. Now see what we did. We started out with how many equations?
2,
2 equations and how many variables?
3, 4.
How many different variables?
2.
2, right? An x and a y. So we started out with 2 equations, 2 variables. But now what did I just write down? I have 1 equation. How many variables?
1.
1, just x. Whenever you have one equation with just one variable, you can solve and figure out the answer and figure out the value of that variable. So now I can basically solve for x. I can figure out the value of x by solving this equation. So we're going to treat this just like a normal equation, like the first thing we ever learned in this class was solving equations. How do I solve this equation? What should I do first?
Distribute.
Distribute, good. So I start off, I distribute, I have 5x plus 8x equals 39. What can I do next?
Combine like terms.
Combine like terms. What's 5 plus 8?
13.
13. So 13x equals 39. And to get x all by itself, divide by 13. And what is 39 divided by 13?
3.
It's
3.
So take a look. Well, look what happened. Now we know we have half of the puzzle figured out. We know the value of x. Step 2 is complete. Now that I have the value of x, step 3 says substitute the value from step 2 into either original equation. So basically we can do what we did in the bell ringer. Once you know the value of x, you can take that number and plug it back into, does it matter which one I plug it into? It does not. You always want to pick the one that's easier though. So in this case, should I plug it into equation number 1 or into equation number 2?
1.
Yeah, 1 is way more easy than number 2. So I just take my equation and I plug in the answer that I got. I got 3, so I'm plugging in 3. 4 times 3 is 12. So all done. My final answer, matter of fact, let me write it this way. My solution is going to be 3, 12.
Miss, I have a question.
Mm-hmm.
Like, why didn't you plug in like how you did in the last equation?
Say that one more time. Explain that for me.
Like, why did in the other equation, you moved the 4x to the 2y? Why did you do that over there?
Why did I do that? So that's always going to be your first step, and because it's called substitution for a reason. Remember what we said, substitution is plugging in or replacing. So all I did is, since I know that y is equal to 4x, sorry, my voice is struggling today. Okay.
Oh, so the 2 had a y.
Exactly. Since I know that y is equal to 4x, all I did was I replaced my y, which was down here, with 4x, since they are equal to each other. Okay? Wherever I see a y, I can now replace that with a 4x because y is equal to 4x. They are the same. Okay, so that's always that's why you always need to isolate your variable first. That's why step number 1 is to isolate. Because once you isolate your variable, you can take whatever's on the other side of that equal sign and replace, substitute. We'll do a couple more examples. You'll see the same thing in the next slide. Okay. Is anyone still copying down the problem? Me. Okay, I'll give you a couple more seconds. And do I have any other questions? Okay, here's a question in the chat. The question is, every time you replace the y or the x, do you multiply? So that's a very good question, because what we had to do in this problem, when I put in my 4x, when I plugged in 4x, we had to distribute, right? We had to do 2 times 4x. So the answer to that question is it depends on what the equation looks like. In this case, I had a 2. I had 2 there. So I had to multiply. But if you don't have a 2, if you don't have a coefficient, then you don't have to multiply. So it really depends on each example. And we'll see if there's an example where you don't have to do it.
Ms. Lopez, question.
Mhm.
What if they didn't put the x last for us? So, like, what if they didn't separate it for us? So for example, if y equals 4x was plus b, how would we be able to take away 4x from the plus b?
Good question. You'll see that, I think, on the very next slide. Yes. Anybody still copying?
I'm done, Miss.
All done? Okay, cool. Okay, so to answer Ijira's question, here we go. So here in this example, first step, right? We got to isolate x or y. Is that already done for us?
No.
Do we see a place where x is all alone or y is all alone?
Oh wait, what if? Okay, never mind.
Okay, where?
I thought it was like y equals 7.
No, all we're looking for is for the x to be all alone or the y to be all alone. So in this case, where do we see that?
May you repeat the question, please?
Yes, so in which equation, number 1 or number 2, is the x all alone or y all alone?
1.
Yeah, equation 1. So y is all alone. When I say all alone, what I mean is all alone on one side of the equal sign, right? Because remember, your equal sign is like your dividing line. So on the left side of that equal sign, y is all alone. On the right side, I have some stuff going on, but that's okay. We're still doing the same thing. So step 1 is done for us. We don't have to do step 1. We can skip it. Step 2 is still the same thing as we did in the previous problem. I'm going to take whatever is on the right side of that equation, so this whole thing right here, and I'm going to plug it in wherever I see the letter y, which is right here. So I'm doing the same exact thing. So I'm going to plug that in. So I'm going to rewrite equation number 2, negative 2x plus, but now I can plug in negative 3x minus 3, because I'm just replacing it. Here, let me color code. You know, I like my colors. Equals 7. So one more time, I went from 2 equations with 2 variables to 1 equation with 1 variable, which means I can solve. And I'm also seeing how in this example, there was no coefficient. In the previous example, I had 2y, so I had to multiply the 4x times 2. But here, y didn't have a coefficient, so now I don't have to do any multiplication.
How will we get rid of the parentheses?
So if you think about it, the y technically has a 1 in front of it, right?
Mm-hmm.
So that 1 is still there. We're basically just multiplying everything times 1, which doesn't really change their values. So I just end up with the same thing. So there we go. So now I have negative 2x minus 3x minus 3 equals 7. What should I do next?
We move the negative 3 to the right as a addition.
We will do that, but before I do that, I want to do something else.
Combine like terms?
Yeah. Let's combine like terms first so that everything is nice and simplified. What is -2 minus 3?
5x.
Positive 5?
-5.
-5. Now let's move the 3. So now I'm going to add 3 to both sides. 7 plus 3 is?
10.
10. Let me move things up a little bit so I can, okay. Equals 10. And my final step is?
Division.
Division. Divide by -5. Okay, so I end up with x equals?
-2.
-2. Step 1 complete. Or sorry, step 2 complete. What do I do now? Now that I got my value for x, what do I do with it?
Add it to the slope intercept.
So
Plug it in the slope intercept.
plug it in, and by slope intercept, do you mean equation number 1 or number 2?
Number 1.
Number 1. So I go back into equation number 1. I'm going to rewrite it. Y equals -3x minus 3. And I'm just going to replace the x with a -2, since that was the answer I got, right? I got -2 as my answer. That -2 goes right back into that equation. So I have y equals -3 times -2 minus 3. So -3 times -2
6.
is positive 6. 6 minus 3 is 3.
3.
So I ended up with my final solution. What would that be?
It is -2, 3.
Perfect. Okay, so I'm gonna go, I have a question in the chat that I want to answer. So if you're still writing, keep thinking of questions you might want to ask me, but I'm answering the following. So how did I go from here, from this to this? So how does anybody want to volunteer to explain that?
You added like terms.
We combined like terms, exactly. So remember that the number you have takes whatever sign is in front of it. So this is -2 minus 3x. So if you're on -2, if you're standing on the -2 and you're subtracting, is that going to become more negative or less negative?
More negative.
More negative, because you're subtracting. You're going further and further down. So -2 minus 3 gives me -5. That's how I got -5x. Any other questions or any other steps that I can clarify?
Miss, I got a question for the equation. Like, how did you start that off? How did you like get those numbers?
This section right here? Or which equation are you talking about?
The equation on the right.
This one.
Yes.
I just went back to my original equation number 1. So that's why I wrote a 1 there.
Oh,
So,
okay.
right, because in once you find the value for x, remember you can plug that number into equation number 1 or equation number 2. You can pick whichever you want, but you always want to pick the easier one. So in this case, equation number 1 looked a little bit easier, so we plugged it into that one. Any other questions? Anybody still writing? Okay, let's do another one. The more we practice, the easier it gets, I promise. Okay, so let's take a look at this example. What is a little different about this one?
There is nothing that is isolated. The variables are isolated.
Right, both of them are, you can say they're both in standard form, right? So they're both, nothing is alone. None of those variables are alone. So we finally have to do step one. We actually have to do this. We have to solve one of the equations for its variables. We need to isolate a variable. Now, you always want to isolate whichever variable is going to be easier to get by itself. So in this case, would you guys isolate the x or would you isolate the y?
The y.
I'm going to isolate one of those. You always want to think, when I say isolate, which one's going to be easier to isolate, you always want to think about which letter has no number in front of it. Which of those variables is already close to being alone?
X.
Right? Yeah, on both equations. The x is already kind of alone. We just have to move one thing out of the way. Because if you wanted to isolate the y, you could do it, but it would take more steps because not only do you have to move the x to the other side, you would also have to get rid of the coefficient. So it would take longer, basically. So you always want to look for whichever variable is already alone, is already kind of lonely, and is closer to being by itself. Now, does it matter if I do the top equation or the bottom equation?
Nope.
Doesn't matter, right? You can choose each one, whichever one you want. So let's do the bottom equation because we haven't really done that one yet. We haven't really worked with that one. So I'm going to go ahead and just write it down. And what I need to do is just move things around so that the x can be all alone. So which variable, what needs to go away? If I'm trying to get x by itself, what needs to go away? The y, right? How do I move that y over?
Subtracting it to the other side.
We're going to subtract it. Exactly. So minus 4y on both sides. So this gives me x equals, we can write it either way, but I'm just going to write 2 minus 4y. Do I have any questions up to this step? Cool. So that was step one. It's pretty painless usually. We're done with step one. Well, now we can basically go ahead and keep going just the way we've been doing it. Now that x is all by itself, I can take everything else, the right side, and plug it back into the other equation. So careful here. Since I just isolated on equation number 2, I have to plug this into equation number 1. You always plug it into the other equation. So I'm going to be plugging this in. Should I be plugging it in for x or should I be plugging it in for y? Where is this going?
Y.
The x? Yeah, the x actually. Why is it going to be plugged in for x?
Oh, okay, because it's equal to x instead of it's equal to y.
Yeah, it's equal to x, so it goes in for x. Exactly. In all the other examples, we were working with the letter y, but in this one, it changed things up a little bit. This one's equal to x, so it goes in for x. Okay, so that's the only thing you got to be really careful with. So now I'm on step 2. I'm going to rewrite equation number 1, but instead of x, I'm writing 2 minus 4y minus 3y equals 9. I went from having 2 equations with 2 variables to 1 equation with 1 variable. It's just that now The only difference is I'm solving for y instead of solving for x. But it's still the same, it's just a normal equation. We're just solving, finding our answer. Any questions before I continue? I want to make sure I clarify everything. I want it to make sense because I know that this can be tricky sometimes.
Miss, I need more explanation.
Okay, do you have a specific place where I can explain?
Number 1.
So in step 1.
Yeah, isolating the variable.
Isolating the variable. Okay. All we did in step 1 we were trying to figure out, okay, how can I get this x to be all alone? And since it's an equation, since I have an equal sign, I know that I can move things around. I know that I can switch things from one side to the other. So all I was trying to do was trying to move the 4y to the opposite side of the equal sign so that the x could be all alone. And we know that if you ever want to move things to the other side of an equation, you have to use the opposite operation, the inverse operation of what you have. So why did I subtract 4y?
We had to do the opposite.
The opposite of what?
Addition.
Of addition, exactly. Since I had x plus 4y, I needed to take away 4y in order to move it around. And that's all we did. That was literally all I did. And then in my answer, I wrote 2 minus 4y because I can't combine these. Why can I not combine those?
Because 4 has a variable.
4 has a variable. So all I did was I rewrote them, but separately. 2 and then minus 4y. That was it. Okay, and then from there, we're still doing, like, that first step was the only different thing we've done so far. From there on, I'm still following the same steps that we've been doing in the previous 2 problems. I just take everything else that x is equal to, and I plug it in. Okay, so let's go from here, and then if you still have more questions, you can put them in the chat. So I'm solving for y. What should I do first?
Combine like terms.
Combine like terms, exactly. Now here's another where we got to just be very careful. This is -4 minus 3. What does that give me?
-7.
-7, good. So I have 2 minus 7y equals 9. Then I see Samantha said it in the chat. We're going to subtract 2 on both sides. What's 9 minus 2?
7.
7. And then we can divide by -7. And what's my answer?
1.
Not just 1.
Oh, -1.
-1. Good. Okay, questions up to that point? Okay. Well, now that I have my y, step 2 is done. What can I do now?
Plug in the y to our original equation.
Exactly. Does it matter which of those 2 equations I use?
No.
No. So which one do you guys want? Shout it out.
Equation number 1.
Number 1. Do I have anyone want number 2? No? Okay, let's do number 1.
Wait, actually, let's do number 2 so we can challenge ourselves.
Okay, sounds good to me. Let's do number 2. X, it's not even that much harder. So I'm just writing down equation number 2, and I'm taking this -1 and I plug it in. Plug it in for y. So x plus 4 times -1 4 times -1 is?
-4.
-4. X minus 4 equals 2. What do I do to both sides?
Add 4.
Add 4. So I get x equals 6. Final answer, final solution.
6 comma -1.
6 comma -1. Beautiful. So this one was challenging, guys. We've already gotten to the hardest type of problem, and you guys are following along. That's really good. It's definitely tricky. It's going to take a little while and a little bit of practice for it to like truly sink in. But as long as you're following along and you're understanding where the numbers are coming from, you're in a good spot. So that's why I'm asking you guys at any point, if you have questions, ask it right away, because I'd rather take time now and clear things up than a week from today you are still lost because you didn't ask questions at the beginning. I believe that the next slide will have, let me check. We'll have some practice. No, we're going to do one more together, and then after that, you'll get the chance to try a couple on your own. Is anybody still copying?
Me.
Okay, take your time.
Miss Lopez, I bet that the next question is gonna be ours to do, like independent.
No, we do have one more to do together. I'm not gonna make you do it alone quite yet.
I'm done.
Okay, great. All right, so here's one more example that's very similar. So again, there's two equations. Both of them are in standard form, so I know I'm going to have to do step 1. But let's figure out which of these is going to be easier to get a variable all alone. Number 1 or number 2?
Always number 1.
Always number 1, isn't it? Okay, yeah. Number 1, the y is already kind of alone. So the only thing that has to move is the 3x, which we can do in just one step. So let's definitely do equation number 1. 3x plus y equals 14. I am trying to get y all by itself, so what should I do to both sides?
Subtraction.
Subtraction. What am I subtracting?
Y.
I'm trying to get y by itself, so I don't want to move the y because that's the one I'm trying to get all alone.
Subtract 3x.
Subtract 3x. There you go. Okay, and so now I have y equals, I could write it either way. I could write 14 minus 3x, or I can write negative 3x plus 14. Doesn't matter which way you write it. I'll do it this way for now, negative 3x plus 14, because that's just how we're used to doing it. All right, so I'm done with step 1. That's how quick that can be. Questions on that one? Awesome. So now I take my right side, and am I plugging it into equation number 1, or am I plugging it into equation number 2?
Equation number 2.
2. Good. You always want to plug it into the other equation. So if you isolated equation 1, you got to plug it into equation 2. Am I plugging this in for x or for y? Where's it going?
Y.
Y. Good. Because again, That's what I solved for. That's where it goes. Goes in for y. So let's go ahead and do it. This is now equation number 2. 2x minus 6. I'm going to plug that in. And from here, I can solve. So I want you guys to challenge yourselves to try and solve this equation on your own. This is a little more challenging than the ones we were doing before, but it's not so hard. You guys have done a similar ones in the past. So I'm going to give you guys about 2 minutes to just at least get started on solving it on your own, and then we'll come back together.
We type it in the chat, right?
Yeah, go for it. Alrighty. All right, let's go ahead and do this together. A couple people got the right answer. Good job. Now you guys can help guide me through how to solve this. So what should I do first? What step should I take to solve this problem?
The parentheses.
The parentheses, exactly. We're going to distribute. So 2x, and now I have to do -6 times -3 is
18.
positive 18, good. So I got plus 18x. Then I have to do -6 times positive 14.
Which will be negative 84.
Good, thank you, Lauren and Najira. -84. Alrighty, what can I do now?
Combine like terms.
Combine like terms, exactly. So now I gotta go ahead and do 2 plus 18. That's not too bad. What do I get here?
20.
20. 20x minus 84 equals -24. Next up.
Add 84 to the right side.
Good, we're adding.
108.
So 20x
Equals
equals what?
60.
60. Okay, very good. Be very careful. We're not doing 24 plus 84. We're doing -24 plus 84. Okay, so think about it. You can think about it like subtraction. You can think about it like 84 minus 24. Or you can think about, okay, if I'm standing on the -24 and I'm adding 84, That's going to be positive. That's going to be positive 60. Be very careful with those negatives. They never go away. They will be there forever and ever in your math classes. You got to make sure you're careful. But one last step, we divide by 20, and we get x equals 3. X equals 3. Questions on solving this equation? It's been a while. But these never go away. So it's always good to keep practicing how to solve equations because they come back. No matter what you're learning in algebra, there's always going to be a little bit of equation solving. Step 2 is done. What do I do now?
Plug the 3 into the first equation again.
Perfect. We're going to plug the 3 into the first equation. Does it matter which equation you chose?
No.
No, but the first one does look a little bit easier, so we might as well. So I'm just plugging in that 3 for x. So 3 times 3. Okay, so I'm just plugging in that 3 and solving from there. 3 times 3?
9.
9. What should I do to that 9?
Subtract.
Subtract it. What's 14 minus 9?
5.
It's 5. Y equals 5. And now I have my full solution. We got 3, 5. Okay? Do you guys agree it gets easier and easier the more you do it?
A little bit.
A little bit, right? This is the type of problem where practice makes perfect. The more you just try it and keep, it's the same process every time, the same 3 steps every single time. So just the more you practice, the easier it gets, which is why in the next slide, you guys are going to get the chance to try it completely on your own. I want you to make mistakes. Make all the mistakes in the world because that makes my job a little bit easier because then I can help you fix those mistakes, okay? So don't be afraid if you get it wrong, that's okay. That's totally okay. We're all learning something completely new right now. But what's important is that you try. Okay, so I'm going to leave this up for just a couple more seconds so you can finish writing. And by the way, notice how neat I am being. Notice how neatly I did step 1 all in one line, step 2 all in one line, step 3 all in one line. It's very useful to do that because there were a lot of steps, there were a lot of things we had to do, and if you start getting all messy, it's going to mess you up. Anyone still need a second to write down? All right, so here we go. 2 examples. You will have to follow step 1. So just make sure you're being very neat about it. I am going to give you quite a long time right now. I will give you 10 minutes. 10 minutes, that's a long time to start on this completely on your own. If you have questions, ask them in the chat or out loud. I'm happy to walk you guys through it if you need some help. But again, make those mistakes, try it on your own. That is totally okay.
I just had a huge brain fart. I forgot everything that we've done.
Does anyone need to write down the 3 steps or has everybody written them down already? Take a picture of them, take a little screenshot so you have them. Okay.
I took a picture.
Okay, cool. Good. Go ahead, get working. I'm doing it too, by the way, right now. There's about 2 minutes remaining. I don't expect everyone to finish both of these problems, but as long as you try number 1 and get as far as you can on number 1, that's good. All right, guys, time is up. Time is up. So I know a few of you got pretty close to finishing number 1. So let's go ahead and try that one out together. Because if you made a little bit of a little error, it's going to be helpful to see how to do it correctly and then figure out where you went wrong. So always when I go through the problem, check your work, look at what you did, and then try to find the place where you went wrong. Okay, so let's go ahead and begin. So I'm solving this system. I need to get a variable all by itself. Which variable looks like a good candidate to get by itself?
For the first one.
Yeah, in the first equation, which variable can I get all alone?
X.
X. So I have x plus 7y equals negative 11. I'm trying to get x all alone, so I subtract 7y. This gives me x equals negative 7y minus 11. Both of those are negative. Okay, next up, what do I do next?
We
Plug in.
Go ahead, RL. What am I plugging in?
You plug in the equation on the right and the second equation.
Good. And am I plugging it in for x or for y?
The x.
For x, good. Perfect. So that guy is going to go right into equation number 2. All right, so I'm plugging in negative 7y minus 11. And I am going to solve for y. This was probably the trickiest step because there are a lot of negative numbers. There will be some addition and subtraction with negative numbers, so we just got to be very careful. But we're just following the same steps. I start with my distribution. Negative 2 times negative 7.
14.
14. Negative 2 times negative 11.
22.
Good. Positive 22. And then everything else comes down. What's my next step?
Combine like terms.
Combine like terms. 14 minus 5y.
9.
9. Okay, now what?
Oh, I did like 22 plus 9y, not 9y plus 22.
Either way works. If you wrote it the opposite way, you're still correct.
We have to move the 22 by subtracting.
Mm-hmm. And what is 4 minus 22?
Negative 18.
Negative 18. And when I do my final step, which is division, negative 18 divided by positive 9 is what? What do I get?
Negative 2.
Negative 2. Negative 2. Since I'm doing negative 18 divided by positive 9, a negative divided by a positive will stay negative. So we end up with negative 2. We are halfway there, my friends. Almost there. But from here on out, it's a little bit easier. What do I do with that negative 2?
We add the y to the original equation.
Okay, do you guys want to plug it into equation number 1 or into equation number 2? 2? Sounds good to me. Again, it doesn't matter which one you want to do. In this case, both of them are pretty equally complicated, so it doesn't matter. So I'm going to plug it in for y. Okay. So we got to do a little bit of math. What's negative 5 times negative 4? Yeah, 20, good. Okay. Now what do I do?
Subtract 20.
Yeah, subtract first. What is 4 minus 20?
Negative 16.
Good, negative 16. And now I divide both sides by?
Negative
2.
Negative 2.
Which will give us 7, right?
Not 7.
Negative 8. I mean 8.
Positive 8.
Yes.
Did everybody else get that? I'm checking in the chat right now.
Yeah. I got 2.
You got 2.
Solution. I did.
Yeah, I had some different answers. A couple people had different answers. What do we think? Did anyone else get 8? Did anyone plug it into equation number 1?
I forgot to plug in. Oh, that's the reason. Okay.
What happened?
Oh, wait, never mind. I did plug it into number 1.
Oh, I see where I went wrong, guys. This is my fault. I was like, this is not what I got either. I don't know why I put negative 4 in there. That should be a negative 2. That's Miss Lopez on low caffeine. I don't know why I plugged in a negative 4. This should have been a negative 2. I'm sorry. So let's do that one more time. Negative 2 times negative 5 is positive what? 10. Okay, then what do I do?
Then you subtract 10 from 4.
Subtract 10 from 4.
Negative 6.
Which is negative 6.
And then you divide negative 2.
There we go. And the negative divided by a negative is
a positive.
a positive. There we go, guys. Sorry. Solution is 3, comma, negative 2. All right. Questions, comments, concerns, anything at all? Ask it now. So this one was, I gave you guys some tricky problems, okay? This one definitely was not easy because there were a lot of steps to it. But it's always good to practice the hard problems because then the easy problems are even easier to begin with. So we have like 7 minutes left. I want to do the second example together, but before I begin it, I just want to let you know that this one was, so if you were trying this one and you were really confused, this one is a challenge one. I kind of gave you a trick question. I don't often do that, but I did in this example. And what we're about to do will continue because there were like a few more slides I wanted to do together. We'll do that tomorrow, okay? So we're not finishing everything today, but that is okay because like I said, I'd rather spend more time on this in the beginning so that we really understand it, and that's totally fine. So here's example number 2. Let's just do this one together because I know most of you didn't get to it. Which equation should I solve first?
Equation 1, and I see where you tricked us by.
Say that again?
I see where you tricked us, maybe. Probably.
You think you see where I tricked you?
Yeah.
Possibly. Okay. So here we go. I need to get y by itself. I'm going to subtract 5x from both sides. But be very careful here because what am I left with on the left side?
Negative
y. I put that.
Negative y.
I didn't know what to do with that negative y.
Okay, well, remember that a negative variable is the same thing as -1 times that variable, right? There's an invisible 1 right there. Well, what do I do anytime I have a coefficient? What should I do to both sides?
Multiply.
Not multiply, but you're close.
Oh, divide.
Yeah, if I want to get rid of that number, all I got to do is divide by -1. Which, what does that do? A negative divided by a negative becomes a positive, and a positive divided by a negative becomes a negative. So what happens is I end up with positive 5x minus 18. Okay, so all that happens is the signs kind of flip. That was the first tricky thing I did. No, because remember, we're not combining these. These stay separate because one has an x, the other doesn't. Okay, now I can move on to step 2. Where am I plugging this in for? For x or for y? Good, for y. Okay, so let's go ahead. So equation number 2, 10x minus 2 times 5x minus 18 equals 32. Awesome. I have my equation. I'm going to distribute. I would end up with 10x, what was that? -2 times positive 5 is?
36. I mean, oh, my bad. 10.
10. Negative 10x. Now plus 36 equals 32. Combining like terms, what do I get?
0.
0, yeah. 10 minus 10 is 0. So I end up with 36 equals 32. Ladies and gentlemen, does 36 equal 32?
No.
No.
It does not. It very much does not. So here is why this was a trick question. This, if you think back to what we talked about yesterday, let's remember that you can have one solution, but what else can you have?
No solutions.
You can have no solution as well as
Infinite solutions.
infinite solutions. Now, in this case, since 36 does not equal 32, this is no solution. No solution. That's our answer, actually. There's nothing else I can do. So we'll talk more about this tomorrow, but basically, the same way that when you're graphing, what does it look like when there's no solution?
Oh, parallel lines.
Yeah.
Right, parallel lines. So when you're graphing and you get parallel lines, that's no solution. But you can also figure out if it's going to be no solution using algebra. Okay, so tomorrow we'll kind of go through all of those sort of special cases, and then we'll go from there. But as a reminder, you do have homework with graphing. So make sure that if you kind of feel a little lost with that, make sure you rewatch. I already posted the video from yesterday's class on the YouTube channel. So it's a good idea to review that one more time or watch the Khan Academy videos or do what you need to do to refresh your memory on that, because I won't be going over that anymore. Yesterday was the only day where I was teaching that topic. All right. Good job today, guys. There was a lot of participation. I was very happy to see that. So keep that up. Have a nice day. I'll see you guys tomorrow.
Bye, Ms. Lopez.
Have a
Bye.
nice day, Ms. Lopez. See you tomorrow.
Thank you, Jara. See you tomorrow. Bye, Allison.